You train a deep research agent with vanilla test time scaling.
It plateaus on long-form reports.
Stumbles on multi-hop reasoning.
You realize human research isn't linear.
It's draft, revise, search, repeat.
You model it as diffusion.
Start with a noisy draft.
Iteratively denoise with retrieval.
It climbs to 69.1% win rate on long-form research.
You add component-wise self-evolution.
Each module plan, query, answer evolves on its own.
Fights information loss in long trajectories.
Deep consult performance jumps to 74.5%.
You watch the synergy.
Self-evolution enriches each piece.
Denoising weaves them into a coherent story.
Search queries get 12% more novel.
Early steps capture 51.2% of final report info.
You test on HLE search.
It hits 33.9% correctness, beats OpenAI DR by 4.8%.
GAA. 69.1% top of the pack.
Translations.
Backbone alone, good, not great.
Self-evolution, better.
Add denoising with retrieval. Game over.
You test on unseen domains.
Biomed, finance, social science.
It still outperforms.
You
didn't train a report generator.
You didn't train a search tool.
You trained iterative deep research itself.
Someone says it's just diffusion on text.
You show the Pareto frontier.
Same latency, far better result.
They say, but other agents use similar tools.
You point to the draft-centric loop.
Guiding search, reducing noise, preserving context.
They go quiet. You realize
that isn't a better reason.
It's a new way to model how research works.
Welcome to the deep dive. Okay, if that little rapid-fire overview felt a bit like eavesdropping on a researcher having a caffeine-fueled breakthrough at 3 a.m., well, you're not entirely wrong.
Yeah, it kind of captures the energy, doesn't it? That was a super quick tour of something genuinely exciting happening in AI research.
Exactly. Today, we're diving into a development that, honestly, feels less like just another incremental update and more like, well, a whole new way of thinking about how AI actually does complex research.
Right. We're not just talking speed here. It's about making AI smarter, maybe even more insightful, by making its process more human-like.
Okay, so let's set the stage for everyone listening. Yeah, so our mission today really is to unpack the core ideas behind this thing called the Test-Time Diffusion Deep Researcher, or TTD-DR for short.
Catchy aim?
Well, maybe. It's from a team at Google Cloud AI research folks like Rujun, Yanfei Chen, Tomas Pfister, and others. And look, if you're someone who needs to get up to speed on complicated topics fast without getting lost in a sea of information, this is definitely something you'll want to understand.
Why is it making such waves then?
Because it tackles this fundamental problem. How do we get AI to do real deep research?
Yeah.
Not just, stringing sentences together that sound plausible.
Okay, let's dig into that. What was the big frustration, the main problem with the existing deep research agents, the DR agents?
Well, these systems, the idea was great, right? AI that acts like a human analyst, but in practice...
They hit a snag.
Yeah, exactly. I mean, the large language models, LLMs, they got incredibly good at generating fluent text. Amazing, really. But ask them to write a really long, complex report, something needing deep synthesis. Or tackle multi-hop reasoning, where you need to connect the dots between different sources, different pieces of information. They often just sort of stalled out.
Like they hit a wall.
Pretty much. They plateaued. And researchers here argue it's because they weren't really designed like human researchers work. They lacked what the paper calls a principled draft, search, and feedback mechanism.
Which brings us to the human element. How do we humans actually do this kind of complex research? Because it's definitely not just writing start to finish.
Oh, absolutely not. Think about writing a big paper or report yourself. It's messy, right? You plan a bit, you draft something, you realize it's not quite right.
You go back, you search for more info, you revise.
Exactly. And this isn't just anecdotal. Cognitive studies going way back to Flower and Hayes in 1981 showed this clearly. Human writing isn't linear. It's this cycle of planning, drafting, and then multiple rounds of revision. And later work, like Catalano's in 2013, pointed out that writers actively go out and look for external stuff, like literature or search results, during those revisions to, bolster arguments, fill gaps.
That iterative process, draft, search, revise, repeat.
That's the key. That's how we produce quality work.
Okay, so here's where it gets really interesting, the connection they made.
Yeah, this is the cool part. The researchers saw this human pattern, this messy iterative cycle, and noticed, as they put it, a striking resemblance to something from a different part of AI.
Which is?
The sampling process in a diffusion model, but one augmented with retrieval. You know how AI image generators often start with random noise?
Yeah, like digital static.
Right, and then they gradually refine it step by step, pulling it towards a coherent image based on the prompt.
All right.
Well, imagine applying that idea to text. Start with a very rough, maybe even noisy draft of a report, like just the bare bones, maybe some errors.
A fuzzy idea of the final report.
Exactly, and then you iteratively refine it. You denoise it step by step, but instead of just using an internal model, you bring in new information through search at each step to make it better.
Ah, I see. So the refinement isn't just algorithmic. It's informed by external knowledge retrieval.
Precisely. That's the core analogy. TTD-DR is built on trying to mimic that human research workflow using this diffusion-like process.
Okay, so it's not just one single trick then.
No, not at all. It's really a combination, a synergy of two core innovations working together, both aimed at capturing and, frankly, improving on that human process.
All right, let's break those down. Innovation number 1.
Denoising with retrieval.
Okay, explain that. So the LLM spits out an initial draft. Might be rough, noisy, as you said, like a first pass.
Yep. Could be an outline, keywords, maybe some half-formed sentences. Critically, it's not expected to be perfect.
Right. And instead of just trying to make it perfect in one shot.
It gets iteratively refined, noised, through this continuous feedback loop.
And the retrieval part is key here.
Absolutely crucial, because the current draft, wherever it is in the refinement process, actively guides the search. It helps the agent figure out what information it needs next.
So it's not just searching randomly.
Yeah.
The draft tells it what gaps to fill.
Exactly. As new information comes in, say, from Google search, it's immediately synthesized and used to revise that draft. They call it a draft-centric design.
Draft-centric. I like
Yeah, and it's powerful because it means the report stays focused, timely, coherent. It's like you as a writer constantly looking at your draft and thinking, okay, I need evidence for this point, and then gonna find it.
And this helps avoid losing track over long, complex research tasks.
Big time. It significantly reduces that information loss you can get in these long agentic trajectories, as the researchers call them. Keeps everything anchored to the evolving report.
Okay, that makes a lot of sense. Constantly refining based on new info.
Yeah.
But you said there were 2 innovations.
Right. The second one is maybe even more intricate. It's called component-wise self-evolution.
Component-wise.
Yeah.
Meaning not just the whole report.
Exactly. This is really wild. It means that the individual components or steps within the agent's workflow are also evolving and improving themselves.
Wait, so like the part that generates the plan gets better, and the part that formulates search queries gets better independently.
Precisely. Generating the plan, formulating questions, synthesizing answers from documents, each of these unit agents, as they sometimes call them, undergoes its own optimization cycle.
Wow. Okay, how on earth does that work?
It's pretty clever. For each step, say, formulating a search query, the agent doesn't just generate one output. It generates multiple diverse options, like several different ways to ask the same question.
Okay, so it brainstorms variations.
Right. Then they use another powerful LLM in this case, Gemini 1.5 Pro, as a judge, and LLM as a judge.
To evaluate the different options.
Exactly. It assesses the variance, gives feedback, assigns fitness scores, basically says, this query is good, this one's okay, this one misses the mark, much like a human supervisor might. Based on that feedback, the variants get revised. And then this is neat. The best parts from these revised variants are merged together into a single, hopefully much higher quality output.
So it's like evolutionary algorithms, but applying to each distinct task within the research process.
That's a great way to put it. And the benefit is huge. It encourages exploring different angles, different ways of phrasing things, different pieces of knowledge. It fights information loss at each step, not just for the whole report.
Which then provides better inputs for the next step, and ultimately for the main report refinement, the report diffusion.
You got it. It creates this richer context for the whole denoising process to work with.
Okay, so you got these 2 big ideas. Denoising with retrieval for the overall report, and component-wise self-evolution for the internal steps. How do they fit together in the actual architecture? What does the TTD-DR agent actually do?
It follows a pretty logical 3-stage backbone structure.
Stage 1.
Research plan generation. An LLM agent kicks things off by creating a structured plan. Think of it like a detailed outline or a table of contents. It's the scaffold for the whole thing.
Sets the direction right from the start.
Exactly. Then you hit stage 2, Iterative search and synthesis. This is the engine room, the main loop.
Where the denoising and evolution happen.
Yes. You have these sub-agents working here. They generate search questions guided by the plan and the current state of the draft. That's the denoising feedback.
Okay.
They retrieve documents, say, from Google search. Then they synthesize precise answers from those documents. And importantly, the self-evolution process is refining how they generate questions and how they synthesize answers throughout this loop.
So the loop keeps running, refining the draft, guided by the plan until...
Until the research plan is basically covered. Until the draft has been denoised enough based on the required information.
And the final step?
Stage 3, final report generation. A final LLM agent takes everything, the initial plan, all the refined Q&A pairs, the synthesized info from stage 2, and weaves it all together into the final comprehensive report.
Gotcha. And the key, as you said, is that self-evolution and denoising aren't just tacked on. They're woven throughout stages 1 and 2, constantly improving the process itself.
Absolutely. It's designed to be a holistic, self-improving system.
Okay, theory sounds amazing, powerful.
Yeah.
But does it actually work better? How do they prove it? Evaluation is always critical.
Oh, definitely. And they were pretty rigorous here. For the long-form reports, they looked at 2 main things. Helpfulness, did it answer the user's need? Was it accurate, easy to read?
Makes sense.
And comprehensiveness, did it miss any key information? For the shorter, multi-hop questions, it was simpler. Correctness, did it get the answer right?
And how did they measure this? Just ask the AI.
No, they used side-by-side comparisons. They put the TTD-DR output next to the output from another leading system, specifically OpenAI's Deep Research Agent.
Ah, direct head-to-head.
Exactly. And they had both human evaluators and their LM as a judge. That Gemini 1.5 Pro model do pairwise comparisons. Which one is better, A or B?
Using an LLM as a judge can be tricky, though. Reliability concerns.
Totally valid point. But they addressed this head on. They specifically calibrated their LLM judge using 200 human ratings first. They basically taught the LLM judge to align better with human judgments, which makes the automated results much more trustworthy than in some past studies.
That's good. Smart. And what about the tests themselves? Were they challenging?
Oh, yeah. They threw some serious benchmarks at it. Things like long-form research that's got 205 licensed real-world queries from different industries.
So actual business needs.
Right. Deep Consult focused on tough business and consulting type prompts. HLE searched this as a subset of a benchmark called Humanity's Last Exam, but specifically chosen for questions that require a lot of external searching, not just reasoning on known facts.
Pushing the retrieval aspect.
Definitely. And GAIA, another benchmark with real-world questions needing complex reasoning and tool use. They really put it through its paces.
Okay, moment of truth. The results.
This is where it gets pretty dramatic. TTD-DR consistently came out on top, like decisively.
Give me numbers.
Okay, for those long-form reports. On long-form research, TTD-DR had a 69.1% win rate against OpenAI Deep Research. On Deep Consult, even higher, 74.5% win rate.
Wow. So nearly 3/4 of the time on Deep Consult, the judges preferred TTD-DR.
Yeah, think about that. And for the shorter, fact-based multi-op questions, on HLE search, it beat OpenAI DR by 4.8 percentage points in correctness, on GAIA by 1.7 points. These are significant margins at the top end of AI performance.
Okay, that's impressive. But how do we know it was specifically those 2 innovations driving the improvement?
Great question. That's where the ablation study comes in. It's one of the most interesting parts of the paper, I think.
Where they take pieces away to see what happens.
Exactly. Systematically disabling parts. So baseline LLMs like Gemini 2.5 Pro without any search tools, they performed poorly, as you'd expect, like 8.6% correct on HLE search, basically useless for that task.
Okay, ad search.
Adding a simple search tool helped, sure, but it still wasn't as good as OpenAI's established Deep Research Agent.
Right.
Then they tested their backbone DR agent. That's the 3-stage structure without the fancy self-evolution or denoising. Better than simple search, but still lagging behind OpenAI DR.
So the basic structure alone wasn't the secret sauce.
Nope. But then they added self-evolution to that backbone, and boom! Performance jumped significantly, enough to outperform OpenAI DR on the long-form tasks. It got a 60.9% win rate on long-form research, 59.8% on Deep Consult. Just adding self-evolution flipped the script.
So that component-level refinement really makes a difference. Why again?
Their analysis showed it significantly increases the complexity of the search process. Not just doing more search, but smarter, more diverse search. It led to richer information gathering, better questions, better synthesized answers.
Okay, so self-evolution is powerful. And then the final step of the ablation.
Adding denoising with retrieval on top of the backbone and self-evolution, that's the full TTD-DR system. That's when they saw substantial gains over OpenAI deep research across all benchmarks. That was the clincher. The combination was clearly more than the sum of its parts.
The game over moment, as the intro rap put it.
Yeah, pretty much. It really highlights how mimicking that iterative human process with both component improvement and draft-centric refinement unlocks a new level of performance.
Let's dig a bit deeper into that denoising part. How exactly does it improve things like timeliness and coherence?
Right, so the paper has some interesting analysis on this. Figure 10a, for instance, shows that the denoising process increases query novelty, meaning how new and different the search queries are by over 12 percentage points as the process goes on.
Because the draft is constantly updating what's needed.
Exactly. It stops the agent from just asking variations of the same question over and over. It adapts the search based on what's already been found and integrated into the draft.
And that helps preserve information early.
Yes, that's the other key finding. They call it timely preservation of knowledge. By step 9 of their diffusion process, the draft being refined by denoising already incorporates 51.2% of the information that ends up in the final report.
Whoa, over half the final info is already locked in relatively early.
Right. It shows that information isn't just being gathered and then forgotten or lost in the complexity. It's being effectively integrated and used to guide the process almost immediately. This makes the whole thing much more efficient and coherent.
So, okay. Massive performance gains, backed by solid ablation studies, and insights into why it works. But what about the cost? Does all this extra processing make it incredibly slow or expensive?
That's a critical, practical question, right? And they looked at this using Pareto frontier analysis.
Comparing performance versus latency, essentially.
Exactly. And what they found was really encouraging. Both the self-evolution component and the denoising with retrieval component were shown to be efficient algorithms for test-time scaling. Meaning you get more bang for your buck, computationally speaking. You get substantial performance improvements for a relatively modest increase in latency compared to simpler methods.
So it's not just better, it's efficiently better.
Right. It suggests these techniques are actually practical for real-world deployment, not just theoretical breakthroughs that need supercomputers. You get much better research quality without waiting forever or breaking the bank.
Which brings us to the bigger picture. They claim this isn't just a better agent, but a new way to model how research works. What does that mean in practice?
Well, it means TTD-DR isn't just fine-tuned for one specific type of task, like summarizing academic papers. They position it as a general-purpose research companion.
So different fields.
Yeah, they test it across diverse industry domains: finance, biomedicine, recreation, technology. It's designed to tackle those really complex questions where standard LLMs struggle, even with basic search access. Questions that require genuine synthesis and investigation.
Because it mimics that human process.
That seems to be the core idea. That draft-centric iterative loop, constantly pulling in external info dynamically. It maintains focus, it guides the research direction, and it crucially avoids that information loss that can plague systems trying to manage long chains of reasoning.
It's really embracing the messiness, isn't it?
It is. It's trying to capture and maybe even improve upon how humans navigate complex information landscapes. It's less about having all the knowledge internally and more about having a robust process for finding, evaluating, and synthesizing knowledge.
Now, they do mention some limitations, right? It's not perfect yet.
Oh, for sure. They're upfront about it. The current work focuses mainly on using traditional search tools. They haven't integrated things like active website browsing or running code yet, which could be important for some research tasks.
Makes sense.
And they also mention agent tuning, like fine-tuning the underlying LLMs specifically for these research roles as an area for future work. But honestly, even with those caveats, the results they've achieved are seriously impressive.
So wrapping this up, what's the big takeaway for someone listening? If you need to get smart on complex topics, what does TTD-DR signal for the future?
I think it signals a future where AI isn't just a fast search engine or a text generator, but potentially a true intellectual partner.
How so?
Because this iterative, human-inspired approach means getting well-informed could become not just faster, but genuinely deeper and more reliable. The AI isn't just retrieving facts, it's building understanding through a process more like our own.
It's moving beyond simple Q&A towards actual synthesis and investigation support.
Exactly. It's about AI helping us navigate that information overload in a more meaningful way.
Which leads to a really interesting final thought.
Go on.
Well, if AI can now model this messy, iterative, nonlinear process of human research so effectively and get state-of-the-art results because of it, what other complex human cognitive skills are next?
That is provocative. Creative problem solving, strategic planning, maybe even forms of artistic creation if modeling the process is key.
Right. Could the next big leaps in AI come not just from bigger models, but from better models of how we think, learn, and create, warts and all?
That's definitely something to mull over. Are we moving towards AI that doesn't just simulate outcomes, but genuinely augments our most complex intellectual processes by understanding them more deeply?
Plenty to think about there. Thanks for joining us for this deep dive into the Test-Time Diffusion Deep Researcher. Hopefully that gave you a good sense of this exciting new direction in AI.